Welcome. This is 3.3 and 3.4, the first recording. Please make sure you have notes with you and a green sheet to work on in order to complete this lesson. If you were absent, that is. We're going to move on now. These are our objectives. We're going to use the change of base formula and properties of logarithms, and then we're going to be solving some different types of equations with logarithms and exponents. Our change of base formula is necessary for most calculators. Our TI-84s, if you have the updated OS, have a log-based function, but most do not. So if you do not have an 84 and you do not have a log-based function, then you need to be using this formula. And all it states is that we take the log base a of b and it's equal to log b over log a. Just remember that sorry about that, this cute little subscript down here stays under. The sub stays under, like a submarine. Sub stays under. So in other words, if I have log 2 of 5, I can rewrite that and put it into my calculator as log 5 over log 2. Now this is true of both common log, natural log base 5, log base 8, doesn't matter. The reason this is so useful, and we usually will use log or natural log, is that most scientific calculators, come with log and natural log functions. Most do not come with the log-based function. So we can use this to put into our calculators no matter what kind of calculator we have. Alright, these are the properties of logarithms. Now remember that a logarithm is an exponent. Given that, remember if we have a to the 1 times let's make that a 4. A to the 2, this is the same as a to the 4 plus 2, which is a to the 6. Alright, same idea. If they're multiplied, add them. If they're divided, subtract them. Now this is another one, raised to the c power, I can bring the c down here in front. This is true also, and we'll look at why that is. If I have log base 2 of 5 to the 4, that's the same as saying log base 2 of 5 times 5 times 5 times 5, 4 5s. Well, look at that first property. We know we could rewrite this as log base 2 of 5 plus log base 2 of 5 plus log base 2 of 5 plus log base 2 of 5. Well, I have 4 log base 2 of 5s, so I can write that as 4 log base 2 of 5. Ta-da! I just brought the exponent down in front. So that's why that works. Now, I oftentimes, in order to avoid minor but annoying arithmetical errors, will treat all subtractions as a -1 exponent. The reason for that is because then all my numbers will fall into place where they belong once I've got them condensed or expanded. Otherwise, I'll end up with incorrect signs a lot of times, or things in the wrong place if I'm not careful. This is just a single situation, but I want you to see why. If I assume this has a -1 here for the negative, and I bring it up as an exponent, as you can see right here, then when I multiply these together, the inside, since they're added, I can multiply them together inside. That -1 drops the 3, which turns this into a 16. Log base 2 of 16 is 4. Now this is just showing you how to do it. We will talk further about the exact situations where we might need it. Alright, so now we're going to do our in-class practice. Now, real quick, I want to kind of talk you through a couple of these things, the answers on these. Okay, A and B should be pretty straightforward. All they want you to do is write them using the change of base formula. 2 gets a little dicey. It's natural log of 3 e to the 4. Well, we can split the 3 and the e to the 4 up. and we get natural log 3 plus natural log e to the 4. I apologize for writing that way. Natural log e, oh, good lord, this thing's going to drive me nuts, to the 4. Ignore that line. Alright, but this becomes natural log 3 of 4 natural log e. Well, natural log of e is 1. E to the what equals e? E to the 1. So that's 1. So that's what gives me my answer of natural log 3 plus 4. Good lord, this thing's bouncing everywhere. Now the reason this one's impossible, if you look at your look at the equation on your green sheet, what's inside the log is negative. That can't happen, can't be, we can't do it. No dice, nada, never. It's impossible. Alright, the other one is 4 because you condense it, divide that big number by 3, and I get 256. It so happens that 256 is equal to 4 to the 4. That's why it comes out 4. Alright, here, this is the one I was talking about that it's going to cause you grief. Let me do this one and show you what I'm talking about. I'm going to erase this, so I have a little more space. Okay, so you're given for number 4, log base 8 of x to the 5th over y to the 5th z to the 8th. Now the problem is, if I try to lay this out right now, most students, and this is wrong, so don't learn this, minus log base 8 of y to the 5th, but that's multiplied by the z, so I would add, sorry, that should be an addition. So I would add log base 8 of z to the 8. Well, that's true, but they're both in the denominator, so you would actually need to put parentheses around. Most students would forget that parentheses and give me that as an answer, or with the numbers brought down, and you'd be wrong. Okay, you'd need to distribute the negative. My way, I turn this into all one line by bringing those out of the denominator. Now when I split this apart, log 8 of x to the 5 plus log 8 y to the negative 5 plus log z 8 of z to the 8. Now I bring my oops, that's negative 8, sorry. I bring my exponents down, and I get this answer right here. Notice the 2 negatives. Unfortunately, many students would come up with that being a positive, and they would be incorrect. So you need to be incredibly careful of that, okay? Now the second one, a lot of people get, or the last one, 5, they get lost in the fact that what you're given is log b of the square root of 3. Well, remember, square root is the same as an exponent of 1/2. So what you're really given is 3 to the 1/2. Well, due to the property of logarithms, I can bring the 1/2 down. I'm left with log b of 3. They give you log b of 3. So your answer is 1/2 times the number they give you for log base b of 3. Okay, when you divide that in half, you should get 0.2823. Alright. Hope you've got that down. I'm going to stop and do a second recording because it's going to take too much time on this recording.